Today, we're going to install the Go development tools on your Windows 11 machine. The latest version of the tools can be found at go.dev. Let's click on the More link from the home page and scroll down. In the middle column, you can see the operating systems that are supported. We're interested in Windows, so the four at the bottom are for us. Notice the 64-bit version in bold at the very bottom. That's the one we want. Also notice the checksum value has been computed for us using the SHA-256 algorithm. We'll use that in just a moment. For now, let's click on the MSI file to download it. When the download is done, let's click on the folder icon to open up an Explorer window. And there's our file in the Downloads directory. Let's open a window to work in. To do that, we'll right-click in the area below the file and select Open in Terminal. PowerShell is the default terminal on my machine. If we run dir, we can see the same file here in our window. As a safety measure, before we install this file, let's compute the checksum for the file we just downloaded. This will help us verify the integrity and authenticity of the downloaded file. The PowerShell commandlet we'll run is get-filehash, space, the name of the file we downloaded, -A and SHA-256, which is the hashing algorithm we'll use to compute our value. In the table it produces, we see the hash value we want. Let's use PowerShell to check this value against what was downloaded on the Golang site. Let's recall the command, and to ensure it runs first, we'll wrap it in parentheses. And we'll use .hash to extract the property we care about, in this case, just the computed hash value. And we'll use the comparison operator -eq to compare the hash value to the value provided on the Golang site. For the moment, let's put in empty quotes. Then go back to the Go site and be careful to get the checksum value that corresponds to the file we just downloaded. In our case, that will be the Windows 64-bit version. Let's copy that. Great. And let's go back to our PowerShell window and paste in the value we just copied between the empty quotes. And press Enter. We get back the value of true, meaning the strings match. So our file is good and we can continue the installation. Let's do that by running the file we downloaded. Up pops the Setup wizard. Let's click Next, accept the license terms, and click Next again. Go will be installed under Program Files/Go, which is fine. So let's click Next, and then click Install. We're prompted with the User Account Control dialog. Let's select Yes, and the installation proceeds. It's pretty quick, and when it's done, we can click Finish. Let's open a new command window to pick up any environment changes by clicking the plus to the right of our existing command window. And let's validate our environment is running correctly by typing in Go /version. In my case, this tells me Go version 1.21.5 for Windows is installed on my machine. Nice. At this point, we have Go installed and ready for use. Before we go, let's write a simple app to test everything is working. I have a directory called Go Projects, so I'll cd into that. To create our first application, we'll need to create a directory to hold our program. Let's create a directory by running the command make dir my first app, and then cd into that directory. Inside the directory, I'll run the command go mod init hello_YouTube. Go projects are called modules. Modules are not just source code. They also contain an exact specification of the dependencies of the code within the module. Every module has a go.mod file in its root directory. Running the go mod init command creates this for us, as we can see when we run the dir command. Running the command type go.mod, we can see the contents of the file. The go.mod file declares the name of the module, in our case, hello_YouTube, the minimum supported version of Go for this module, and any other modules that our module depends on, in this case, none for us. You can think of it like the requirements.txt file for Python or the gem file for Ruby. Now let's write some code. No need to get fancy here, I'll just use Notepad. Feel free to use VS Code or whatever you like. I'll run the command notepad hello.go from the command line and enter the code. The first line is a package declaration. Within a Go module, code is organized into one or more packages. The main package in a Go module contains the code that starts a Go program. Next, there's an import declaration. The import statement lists the packages referenced in this file. We're using a package called FMT, usually pronounced FUMPT from the standard library. Go programs start from the main function in the main package. We'll declare the function with funcMain and enter curly brace pairs to denote the code block. In the body of the code, we'll have a single line that will call the printLine function from the FUMPT package. Our argument will be the message "Hello YouTube" enclosed in quotes. Notice there's no semicolon at the end of the line. Let's save that code in Notepad, close Notepad, and go back to the terminal window. Let's run dir once again to see our code was saved. And now let's create an executable by running the command go --build. It takes just a moment to run. If we run dir once again when it finishes, we'll see a file called hello_youtube.exe was created. The name of the binary matches the name of the module declaration by default. Let's run the executable file from the command line, and we get the message "Hello YouTube" as we'd expect. Very cool. The Go command provides access to a lot of Go development tools. If you run the Go command, besides the compiler we just saw, there's also a code formatter, dependency manager, test runner, and a linter. Alright, that's it for this time. Thanks for watching, and remember to always begin secure.